constructs, what formalisms did we see last time? Sorry? Causal loop diagrams. Good. Can we run a causal loop diagram? Can we simulate it? Can we execute it and see how it behaves over time? No. Okay. Thought provoking. But with the current state of the art, no. Can we reason some about the behavior of a causal loop diagram over time? Kind of. Okay. So what sort of thing? So if we see a positive feedback loop, it may well be associated with what sort of behavior? Unstable, divergent behavior that leads to exponential growth in a certain direction. So a change is magnified by that loop. And with a balancing loop, we have behavior, if the time constants are short, if there's no long delays, what sort of behavior do we see out of it? Decay. Decay towards some stasis, some equilibrium, all other things being equal. Oh, wow. But it's really when you have an interaction between several sets of loops that you get very interesting composite behavior. And we saw last time that often that behavior involves shifting dominance among multiple loops, a concept that can be given mathematical rigor and defined quite precisely with quantitative models. So it turns out we're not leaving causal loops entirely behind. You'll see that much of what we reasoned about in the context of causal loops and their value in providing insight is retained when it comes to quantitative simulation models. But with a quantitative model, we can further simulate the model. We could specify a model with a level of precision that allows us to simulate the change seen over time. And allow us to, for example, run different what-if questions. What if this parameter were larger or smaller, etc. So today we're going to be talking about these key building blocks of quantitative models known as stocks and flows. Okay, stocks and flows. Now so I'll just